Welcome to the third and final PV3X summary video. In the previous part we discussed balance of system components. Now we'll continue with AC yield calculations and financial aspects. Depending on the system configuration, we can distinguish three main types of PV systems: grid-connected, standalone and hybrid. The basic PV system principles and elements remain the same. Systems are adapted to meet particular requirements by varying the type and quantity of the basic elements. In this course we looked into two different approaches to perform a simplified design of a PV system. In the first design strategy, a very rough estimation of the PV system design is performed with minimum inputs by knowing only the number of loads, their daily operational time and the type of PV module used. On the other hand, the second design strategy can be used if additional details such as charge controller input, maximum power point tracking usage, inverter usage or other components are also known. The resulting system design from this strategy will be closer to reality than the former strategy. In any type of PV system design, an analysis of the different load demands is one of the first steps that needs to be carried out. The advantage of carrying out a good load analysis is that it leads to an optimum PV system design by estimating the correct number of PV modules. In this way, an accurate sizing of the PV system can be achieved. In the first video of this summary, we mentioned that the instantaneous DC yield of a PV system can be calculated using the formulas shown in this slide. These formulas consider the effect of irradiance and temperature to determine the electrical power generated by a PV module. Using the instantaneous DC yield and knowing the losses in the different balance of system components, such as cables, maximum power point trackers, inverters, charge controllers, etc. it is possible to calculate the AC yield generated by the PV system. The calculation of this yield is important to know how much power can be effectively delivered to the AC loads in the system. However, in general there is a mismatch between the load demand and AC yield of a PV system. This mismatch can be supplied using a storage system. The preferred energy storage system for PV system with daily and monthly mismatches are batteries. Batteries allow to meet the load demand in hours when the production of the PV system is lower than the load demand. In week 6 we learned that one of the simplest forms of modeling a battery is by considering a voltage source with an internal resistance. This simple model allows to perform energy balances and calculate the loss of load probability of a PV system. In particular, we looked into a strategy to control the charging and discharging of the battery in a PV system depending on its state of charge. In the last week of the course, we looked into the financial aspects of PV systems. We defined the concept of levelized cost of electricity, which is a useful indicator to compare the generation cost of electricity between the different sources. Two other important concepts related to the levelized cost of electricity are grid and socket parity. Reaching grid parity is the point where investing in a solar power becomes economically desirable as the investor will make money over the lifetime of a PV system. Socket parity refers to the moment when the levelized cost of electricity of solar becomes lower than the retail price of electricity, that is the price that consumers pay for electricity. Finally, we discussed two different schemes to compensate owners of PV systems for electricity they deliver to the grid: feed-in tariffs and net metering. Feed-in tariffs are the price that is paid to the PV system owners for how much energy they generate. This price can be above, below or equal to the retail market value. Net metering is basically a special case of feed-in where the feed-in tariff is set at exactly the same price as retail energy. This concludes this PV3X summary. I'd like to remind you that if some of the topics seem unfamiliar, we encourage you to return to the PV3X course and revisit those topics. I wish you good luck with the upcoming exams.